Assalamualaikum warahmatullahi wabarakatuh, and good morning to Dr. Tan and my friends. So today, my group 4, are going to present a structure of Caesium chloride CsCl. So my name is Siti Fatimah Binti Azman, and my metric number is 20A337. My group members are Latifah Binti Muhammad Hassan and also Kirtana Krishnasamy. So next, I will pass this presentation to Latifah to explain about the unit cell and the lattice type, and also the unit formula of the CsCl.
Thank you, Fatimah. Now, I will present about the introduction of caesium chloride. Caesium chloride is an ionic compound in solid form. It has ionic bonding, in which it is a chemical bond formed by the donation of electron from a metal atom to a non-metal atom, which held by a strong electrostatic forces. The caesium atom is located in group 1, which is alkali metal, while chloride atom is located in group 70, which halogen, which then make it classified as metal halide. Now, I will explain about the unit cell and lattice type of caesium chloride. Caesium chloride is a type of unit cell that is commonly mistaken as body-centered cubic, since there is a center atom in the unit cell. But caesium chloride is a really non-compact structure type. Caesium chloride crystallizes in a simple cubic unit cell and has cubic arrangement. Caesium is located in group 1 at the bottom. Therefore, caesium is very big in size, whereas chloride is from group 17. Therefore, caesium will be the lattice in general. The lattice is formed from the large ion, which is anion. However, in this case, caesium ion is bigger than chloride ion. Therefore, caesium will be the lattice. Caesium chloride crystallizes in a primitive cubic lattice, which means the cubic unit cell has knots only at its corners. The structure of caesium chloride can be seen as two interpenetrating cubes, one of caesium ion and one of chloride ion. It has a cubic unit cell with each corner occupied by a cation, which caesium ion, and an anion, which chloride ion, occupying the cubic hole at the center or vice versa. It has unit cell vector A equals to B equals to C and interaxial angle alpha equals to beta equals to gamma equals to 90 degrees. Next, I will continue about the unit formula of the structure of caesium chloride. This is our model for caesium chloride. As I can show you from our model, the orange at the corner refer to caesium ion, while the blue one at each of the center of the small unit cell refer to the chloride ion. Each chloride ion is surrounded by 8 caesium ion at the corner of its cube. The caesium ion fills in the lattice. Thus, the unit formula of the caesium ion is 1 atom, which the 8 corners times with 1 over 8. Next, the chloride ion fills the octahedral whole side. Thus, the unit formula of the chloride ion is 1 center multiplied with 1, resulted in 1 atom. Therefore, the unit formula of caesium chloride is 1. Next, I will pass my presentation to Fatimah.
Thank you, Latifah. So next, I will present about the location of atoms or ion in caesium chloride CsCl. Caesium chloride CsCl has the cubic structure that consists of infinite chain of ion. From our structure, the orange one is the caesium ion, while the blue one is the chloride ion. The caesium ion will fill at the 8 corners of the cube, while the chloride ion will fill at the center of each cube. This means that the caesium ion will fill the primitive cubic lattice, while the chloride ion will fill the octahedral whole side at the center of the cubic. Since caesium chloride has different atoms at the corners and the center, they are not translationally equivalent sites. Although chloride ion occupied at the center of the cube, but it is not regarded as body-centered cubic BCC because it is not the same ion. If the corners and the center of the cube consist of same atom, for example caesium, so it can be body-centered cubic BCC. Therefore, caesium chloride CsCl stay as primitive cubic lattice. Caesium chloride CsCl structure is topologically identical. So what does it mean by topologically identical? So topologically identical means that if we swap the position of anion and cation, the coordination number and the unit formula of the structure will remain the same. So just now we said that our structure has lattice Cs plus, but this now we change to Cl minus as the lattice. So if we choose Cl ion as the lattice and will occupy at the 8 corners of the cube, while the Cs ion will fill at the center of the cubic, so the coordination number Cn and the Z unit formula for the structure will remain the same. So this is mean by the topologically identical. So we change the Cs and Cl, the value is remain the same. So that's all from me. I will pass the presentation to Kirtana.
Next, for the coordination number of cesium chloride, the charge number ratio of cesium ion and chloride ion will be 1 to 1. Is it because the charges are positive 1 and negative 1 respectively? Based on the diagram shown, the coordination number of cesium ion will be 8. Hence, we can conclude that the coordination number of cesium ion and chloride ion will be 8 to 8. Next, for the applications of cesium chloride, firstly, radioactive in cesium chloride is used in some types of radiation therapy, which is for cancer treatments. As a second application of cesium chloride, a thin layer of cesium chloride can enable the production of electrically conducting glass and also can boost the efficiency of solar cells. Next, cesium chloride also used as precursor to cesium metals by high temperature reduction. Next, the application of cesium chloride is it also used in ultracentrifugation, a process that uses the centrifugal force to separate mixtures based on their molecular density. Besides that, another application of cesium chloride will be, it is used as a solid for ultracentrifugation in a technique known as isopycnic centrifugation, which is to allow the separation of DNA of different densities. Next, the application of cesium chloride will be, it is used as reagent in traditional analytical chemistry for detecting inorganic ions, which is mostly detected by the color of precipitations formed. Not only that, cesium chloride composed of radioisotopes that used in nuclear medicines. For example, it is used in brachytherapy. Furthermore, as an application of cesium chloride, it is used in the preparation of electrically conducting glasses and screens of cathode ray tubes. Next, it is also used in activation of electrodes in welding, manufacture of mineral water, drilling muds and high temperature solders. Additionally, as an application of cesium chloride, it is used for cuvettes, prisms and windows in optical spectrometers. Is it because cesium chloride single crystals have wide transparency range from UV to the infrared? Last but not least, application of cesium chloride will be, it is used in electrophysiology experiments in neuroscience, as cesium chloride is a potent inhibitor of HCN channels. Hence, that is all for our presentation about cesium chloride. Thank you.